So in this example, we have a boat that is secured to a pier with two ropes in red and in blue. The tensions in those ropes are both 48 newtons. The red rope is in a direction of 16 degrees north of east, and the blue one is 16 degrees south of east. Assuming that the wind is blowing due west, determine the force of the wind. So really what we have here is a boat that is not in motion. And this is a key thing. Because the boat is not in motion, the force of the wind must be exactly equal to the force of the ropes. And since the wind is blowing due west, we only need to deal with how strong the force is to the east with those ropes. The complicating factor is that those ropes are not at a due east direction, they are at an angle off of east. So to deal with this, we need to actually deal with each rope independently. Now what I've done here is I've blown up the picture and cut out a little bit of it so we can see exactly what we need to. What we need to find with rope 1 is we know that this force here is 48 newtons. Some of that is directed to the east, some of that is directed to the north, some of it is directed to the east. We need to determine how much of that force is directed to the east, and because we have a right triangle, we can use SOHCAHTOA. 16 degrees is the angle, the eastward force is the adjacent side, 48 newtons is the hypotenuse, so we can use cosine here. Substituting in what we know, cosine of 16 degrees equals x over 48. Cosine of 16 is 0.96126, which equals x over 48. Cross multiplying, going to two sig figs, we get 46 newtons, and this is to the east. Same process applies for rope 2. We have 48 newtons acting on the rope. We need to determine how much of that force is acting horizontally. Same exact process because we're still looking for the adjacent of this triangle. Everything else is actually the same. We have the same force, we have the same angle, so it will work out the same, and we will get 46 newtons east from rope 2 as well. So the total force from the ropes, which I'm going to call Ft because the tension in the ropes, is going to equal 46 newtons east plus another 46 newtons east. So we have a 92 newton east force between the two ropes. Since this boat is not moving, means that the net force must be 0. In that case, the force of the wind must also be 92 newtons. However, the force of the wind is acting to the west.